This question starts with two definitions, and we're asked firstly to define a type 1 error and then to define the size of a test. Now, these are actually closely related. A type 1 error is when you reject the null hypothesis when it was actually true. You reject the null hypothesis and you shouldn't have. So that's the error you've made. You've rejected H0, but H0 was true. So we've come to an incorrect conclusion. Well, the size is just the probability of this happening. So the size of a test is the probability of a type 1 error. The question goes on to tell us that Jane claims that she can read Alan's mind. To test this claim, Alan randomly chooses a card with one of 4 symbols on it. He then concentrates on the symbol. Jane then attempts to read Alan's mind by stating what symbol she thinks is on the card. The experiment is carried out 8 times, and the number of times, this is going to be X, the number of times that Jane is correct is recorded. The probability of Jane stating the correct symbol is denoted by P. A hypothesis test is carried out, and the null hypothesis used is that P equals 0.25. The alternate hypothesis, P is greater than 0.25, and there's a critical region where X is greater than 6. A lot of information there, and we've been asked to find the size of this test. I'm going to start by summarizing some of this information. So we have our null hypothesis, our alternate hypothesis, and I'm also going to state the distribution here. So X follows a binomial distribution, N equals 8, P equals 0.25, and there's the critical region. I'm going to make sure to use a value that we're actually interested in. So I'm using X is greater than or equal to 7. The size of the test is going to be the probability of the critical region using the original parameter. So it's the probability that X is greater than or equal to 7. Using our BCD, we get quite a small probability here, 0.00038. So in part D of the question, we're asked to show that the power function of the test is this expression. Let's go ahead and find the power function. Well, the power of any test is going to be the probability of the critical region with the new parameter that's been defined. We don't actually have that parameter, but our critical region is the probability that X is greater than or equal to 7, which individually is the probability X equals 7 and the probability X equals 8. This is the binomial distribution. I'm going to use the binomial probability function for each of these probabilities. So that's 8C7, P to the power of 7, Q to the power of 1, and then 8C8, P to the power of 8, Q to the power of 0. Now, each of these can be simplified, and 8C7, that's just 8, P to the 7, and Q I'm going to rewrite as 1 minus P. Then we have 8C8, which is 1, P to the power of 8, and Q to the power of 0. Once again, 1. I'm going to expand the brackets and collect like terms. And here we have it. 8p to the power of 7 minus 7p to the power of 8. And this is the exact power function that we were asked to find. Next, we're actually given a value for p. Given that p equals 0.3, calculate the power of this test. So I'm just going to need to substitute 0.3 into this expression. So when p equals 0.3, the power is going to be 8 times 0.3 to the power of 7 minus 7 times 0.3 to the power of 8, and we get 0.0013. In part F of the question, we're asked to calculate the probability of a type 2 error. The probability of a type 2 error, well, that's going to be the probability of the acceptance region using the new parameter. If the critical region was greater than or equal to 7, the acceptance region is less than or equal to 6. And now that we know that the parameter is p equals 0.3, we're doing this binomial calculation. The minimum, 0. The maximum interested in is 6. N is 8 and p is 0.3. And that gives us 0.9987. Do be on the lookout though, because we should know that the power and the type 2 error add together to give us 1. They are exhaustive. They're both the critical region with the new parameter, and the acceptance region with the new parameter. So adding them together should give us a probability of 1. We could have done 1 minus the power to get the probability of the type 2 error. Okay, part G asks us to suggest 2 ways in which we might reduce the probability of a type 2 error. Well, to reduce the probability of a type 2 error, we can either increase the number of trials, which means there are more individual outcomes and each of them can share a proportion of the probability distribution, or we could increase the significance level or the critical region. Both of these are equivalent to each other. Increase the significance level of the test, which is increasing the critical region. So those are ways in which we can reduce the probability of a type 2 error. The question could have been phrased as how can we increase the power, because reducing the type 2 is increasing the power. And these two would be valid reasons for that as well.